Welcome back, everybody. This is the last of our 4 review videos for Chapter 10 for this week. So if you're keeping score, we are almost caught up to where we were 3 weeks ago, so we're getting there. In 10.4, we're talking perimeters and areas of similar figures. Okay, objectives to find perimeters and areas of similar figures. Let's get going with that. Now here's the big idea that this whole section's about. We're going to say that if the scale factor of 2 similar figures is a to b, then the ratio of their perimeters is a over b, but the ratio of their areas is a squared over b squared. Okay, what does this mean? This means that if I take a, we'll say square, and I double its dimensions, so let's make it twice as wide and twice as tall. Okay, the scale factor of its perimeters, or the ratio of the perimeters, is the same as the scale factor of the original figures. Okay, now one has twice the perimeter of the other. Okay, the area doesn't work that way though. Notice that right now I could fit 1, 2, 3, 4 of these little squares into the big square. Okay, 4 is 2 squared, so when I made this square twice as long and twice as wide, we made the area 2 squared, or 4 times as big. Let's take a look at what that means for some different problems. Okay, problem 1 just says find the scale factor, ratio of the perimeters, and ratio of the area of the 2 similar trapezoids. So let's say these trapezoids are similar. Okay, same shape with different dimensions. The scale factor is just the length of one over the length of the other. We could say 9 over 12, which we could reduce down to 3/4. Okay, the perimeter ratio is just the same as the scale factor, 3/4. Okay, so when I say the scale factor of these 2 similar figures is 3 to 4, that means their perimeters are in the ratio of 3 to 4 as well. Okay, the area is not going to be the same. What the area is going to be is that scale factor, 3/4 squared. All right, so in other words, 9/16. And that is the big idea here. The areas and scale factors, or the lengths, are not proportional to each other. Okay, we could say the area is proportional to the square of the lengths. If I want to deal with areas, I need to square that scale factor. All right, so let's take a look at using that idea to solve for some areas. Okay, problem 2 says the figures are similar. The area of one polygon is given. Find the area of the other. So I know the larger rhombus has an area of 500 meters squared. I don't know what the area of the smaller is. We'll call that x here. Okay, when I'm dealing with similar figures, I want to use proportions. So what I could do is I could set up that 10 over 25 for the lengths is equal to x over 500. Okay, this isn't going to work. Why isn't it going to work? Well, the 10 and the 25, those are lengths. The x I'm looking for in the 500 are areas. We just said, so this isn't technically correct, but for all intents and purposes, lengths and areas are not proportional to each other. They're not the same thing. So I actually can't use this. I can't do this. What I need to do is I need to square my lengths to give me an area ratio. So the proportion I'm actually going to solve here would be 10 squared, which is 100, over 25 squared, which is 625, is equal to x over 500. Okay, now this is an area ratio, and I can use that to solve for areas. So I can cross multiply and divide. Okay, 625 times x is just 625x. That's equal to 100 times 500. That's going to give me a 50,000. Cross multiply and divide. And we end up with x is equal to 80. We're talking area, so 80 meters squared, we could say for this one. Okay, just summing that up, we want to solve for really anything with similar figures. We want to use proportions, but if I want to use lengths to solve for areas, I need to square those lengths to make an area ratio before I can cross multiply and divide. All right, let's take a look at an application of this idea. Okay, it says it costs James $3.95 to print a 12-inch by 16-inch photo. At this price, how much would it cost him to print a 24-inch by 32-inch poster? Okay, how much would it cost us to make a similar figure blown up? Okay, here's what I can do for this. I only need one dimension from each of these photo sizes. So I'm going to take the smaller dimension. You could use the larger dimension as well. But I'm going to say we have 12 over 24. And then that's equal to $3.95 on top, because that goes with my smaller poster. Okay, over X for a cost. We don't know that cost on the bottom. And I can do this because we're not necessarily solving for an area, but that price is going to be based on the area. Okay, again, this won't work. What I need to do is I need to square my lengths to make an area ratio. And at this point, what I can do is I can just multiply it the way I see it, cross multiply, x times 12 squared. I'm just going to call it 12 squared x. Show you how to save some steps on the calculator here. Okay, is equal to 24 squared times 395. When I plug that in, I get a 2275.2. Let's cross multiply and divide. I'm just going to divide this by 12 squared then. And what I'm left with then is x is equal to 15.8. I'm going to say 15.80 because we're talking dollars and cents. All right, that's how you can use the same idea from the last problem, squaring the lengths to make an area ratio to solve for cost or really solve for anything that's based on the area. All right, let's do one last problem. And this is really going to be the opposite of what we've just been doing. Okay, it says two similar trapezoids have areas of 72 and 32. We could say meters squared for this one. Okay, the longer base of the larger trapezoid is 12. Okay, what's the longer base of the smaller trapezoid? All right, so this one, like I said, is the opposite. In this case, I know my areas, 32 and 72. And I want to use that to solve for a corresponding length in x, okay, the length of this longer base. Okay, for that, again, we're going to set up a proportion. I'm going to say 32 over 72 is equal to x, the side we don't know goes with the smaller trapezoid, so we'll put that on top, x over 12. Okay, with this one, I don't need to, but just to make my numbers work nicer, I'm going to reduce both of these. Okay, I can divide both 32 and 72 by 8. So I'm going to rewrite this as 4 over 9 is equal to x over 12. And that's just going to give me nicer numbers to work with. Okay, now this is not going to work. Why is it not going to work? Okay, because the 4 and the 9 came from areas. The x and the 12 are lengths. Like we said, areas and lengths are not proportional to each other. So just like in the last question where I squared the lengths to get area ratios, what I can do with this one is square root the areas to get length ratios. That's going to make this a length ratio then. So what I can solve then is 2 over 3 is equal to x over 12. These are both ratios of lengths now. Now I can cross multiply and divide and find that missing length. Okay, so I have 3x is equal to 24. All right, so that means that x is just equal to 8 and we'll say meters squared, because this time we're not solving for an area, we're solving for a length. Right, there you go. That's it for 10.4. I guess to reiterate, the big thing from that lesson is if you're setting up a proportion that deals with both lengths and areas, you either need to do some squaring or square rooting to make that proportion actually hold true before you can solve it. Okay, so everything for this lesson, you're either going to square or square root when you're solving proportions. Okay, that's it for our little review week. Get the rest of that Math Excel assignment done. And then from there, give those 2 Math Excel quizzes a shot. Okay, take them, see how you do. Remember, if you do the reteaching assignment, you can retake it. All right, give those a shot. And like usual, if you need help, if you have a specific problem you're stuck with, join me on my office hours. We'll help you out.